45. Ayan. So, a steam power plant operates on an ideal regenerative cycle. So, steam enters at 6 megapascal and 450 degrees Celsius and is condensed in the condenser temperature at 20 kilopascal. So, kinonvert ko na dyan class yung 20 kilopascal into MPa, which is 0.02 MPa. Yan. Assuming that the feed water leaves the heater at the condensation temperature. Yan, madami po siya. Of the extracted steam, and the extracted steam leaves the heater as a saturated liquid and is pumped to the line carrying the feed water. Ayan. So, mahaba-haba to. So, what is now, the steam is extracted from the turbine at 0.04 MPa. Ayan. So, hinapanat dito yung network output per kilogram mass of steam flowing through the boiler in the thermal efficiency of the cycle. Ayan. So, we have, ano yung parts na meron dito sa Feedwater natin? So, mamaya na yung mga numerical. Dito muna tayo sa schematic diagram of a closed feedwater heater or the closed FWH. Okay. So, this is another type of feedwater heater that is frequently used in steam power plants. Yan, na closed feedwater heater natin. Kung kanina open feedwater heater, so ngayon, closed. Basically, dito sa closed feedwater heater, the heat is transferred from the extracted steam to the feedwater without, take note, without any mixing taking place. So, anong pinagkaiba? Sa closed feedwater heater, there is no mixing, while in a open feedwater heater, meron nangyayaring mixing of the steam or the two streams. Okay. So, yung two streams natin, ayan na, makikita niyo yung 1 minus m dito sa 5. 1 minus m pa din dito, class. Ayan, makita natin. So, take note, 1 minus m natin dito, class. Is 1 minus m. So, yung two streams natin now can be at different pressures. Ayan. Since they do not mix in a closed feedwater heater, hindi sila nag-mix. So, from 0.5 to 0.9, hindi siya naapektuhan ng 2 to 6. Ayan. Same pa rin yung stream natin or the mass entering from 0.2 to 6 and entering from 5 to 9. Anong tawag dito, ma'am, sa 7, 8, 9? Ang tawag po dyan, class, is the mixing chamber. Ito na po. Kung kanina, we have an open feedwater. Ito, class, pag sa closed feedwater, saka pa lang, after leaving the closed feedwater, saka pa lang sila mag-mix dito sa tinatawag na mixing chamber. Ito, class, yung mixing chamber natin. Okay? So, that is now we're in yung anong dinagdag dito, class? Dinagdag dito si mixing chamber compared to the open feedwater heater. So, same pumps. We have two pumps from the condenser and from the closed feedwater heater. Yan. This is the basic schematic diagram of a closed feedwater heater. Ayan. How about the TS diagram? Same lang, class, but maduduling ka lang dito. Kung kanina, draw ko lang dito sa kabila kung kung magiging open feed water heater to. Diba? Direkta lang, class. Pag ganito. Ditong part, ganito. Ayan. From 4, 5, 6, 7, papunta na to sa boiler. Ayan. Point 1. Ito. Point 2. Considering saturated liquid. Point 3. So, dito class, nagkakaroon na ng mixing chamber. So, from process 5 to 7, ayan. Hindi na siya class dito sa pumunta dito. Sa schematic, di na siya dumaan dito. Kung kanina pupunta pa siya dito sa 6, eto direkta na class kasi hindi naman sila nag-mix, 'di ba? In a closed feed water heater, hindi naman sila nag-mix. Automatically, doon sila mag-mix sa taas. Ayan. Magulo, ma'am. Ayan. From 4, 5, 6, di ba? Dito, class. From process 4 to 5, pupunta sa 9. So, dito lang pupunta sa 9. Ayan. Diyan sa gitna niya. After that, si 6 to 7, magmi-mix na sila. Babalik siya dito, class. Pabalik siya dito sa gitna para mag-mix. After that, punta na doon sa boiler natin. Kasi same pressure naman. Okay? So, paano na yung pagsosolve natin? What is now the process in solving a closed feed water heater? Yung pinakauna natin. The given in the problem is 6 megapascal and temperature 450 degrees Celsius. Using the steam table, this falls under the superheated. We have now the H1 and the entropy at point 1. So, kinuha lang natin yung necessary or the needed state points. Ayan, walang internet. Ayan. Balikan natin. So, the pressure 1 is given as 6 MPa and the temperature 1 is 450. So, di ko na i-explain pa. I mean, babalikan ko pa ba kung bakit siya superheated. So, that is now your state points or the properties at point 1. We have the enthalpy at point 1 and the entropy at point 1. From process 1 to 3 class, take note that is a constant or tinatawag nating isentropic process. So, S1 is equal to S2, which is equal to S3. Since from point 2, excuse me class, yung point 2 natin kasi papuntang feed water heater. So, S1 is equal to S2. Finding the quality at point 2, we have 96.55. And given sa atin yung feed water entering pressure, which is 0.4 MPa. So, kukunin natin enthalpy at point 2. So, nakuha na natin 2,664.92 kJ per kilogram. So, makuha natin to using the first solving the quality of the steam at a given. Using the, given sa atin yung S1, sabi ko nga, constant, yung entropy natin. So, from process 1 to 2, it will undergo a constant or the isentropic process. Okay? So, we have now the pressure at point 1 and the pressure at point 2. Okay. After that, yung pa-point 3 class is a condenser. Babalikan nyo ito dito sa schematic diagram natin. Ano yung point 3 natin? Pa-condenser. Ayan. Since the pressure is given in 20 kilopascal in the problem, convert it into MPa. Okay, you convert it into MPa. After that, sabi ko nga, isentropic process from process 1 to 3. Yan. We have S1 equal to S2, which is equal to S3. Yan. Paano natin mako-consider that it falls under the wet region? Sabi ko nga, if the given Pag ang given natin class, yung S natin is less than sa SG natin, automatically nag-fall yan sa wet region. Pero kung yung S natin na nakuha is greater than, superheated yan. Okay, superheated vapor. Okay. From pressure 3, we have 0.02 MPa. So that is now a constant isentropic. Yes, tama. Isentropic process. So this falls under the category of the wet region again. So hanapin mo yung quality at point 3. We can now find the enthalpy at point 3, which is now equal to 2,213.26 kilojoule per kilogram. So check na yung point 1, point 2 natin, point 3. Now we move on now to the pressure or the work of the pump using the approximation. Okay? Approximate pump work. Alam natin that process 3 to 4, ano yung process 3 to 4 natin? That is from the condenser. So, constant pressure nangyayari dyan, class, 3 to 4. So, 0.02 MPa. Alam natin from 0.3 to 0.4, yung H4 natin. Paano nakuha natin yung H4? That is ito ba, class? Pangit ang pansulat niya. Ayan. Ito baga, class, since constant yung pressure test sa 3 and 4, this is H3. Ayan. Let me continue. Saan na tayo? Okay, since this is now and balik tayo. So, in process 3 to 4, we all know that is a constant pressure or isobaric process. So, HF3. So, this is now a constant. Ayan. Constant yung pressure natin. So, baliktad. And this is equal to PF3. Okay? So, be given sa atin yung condenser pressure natin. Makukuha na natin using the steam table. These values. Ayan. Sabi dito, yung pressure at 0.5. Ayan. Pressure at 0.5, pressure at 0.10, pressure at 0.8, pressure at 0.7, and pressure at 0.1 is equal to 6 MPa. Ayan. Dito yung class, 5, 9, 8, 7. So, constant yung pressure natin, which is equal to 6 megapascal. Sabi ko kanina, in an open feed water heater, we make use of the approximate pump work of the two differences or the two pump or from the condenser to the pressure at the condenser to the pressure at the boiler. While here in an open feed water heater, we compute for the different pump work in each process. Okay? Since we have the 0.1 sa condenser baga class, From the condenser to the closed feed water heater, yun yung first pump work natin. So, this is now your pressure at the condenser and the pressure at the feed water heater. Okay, the P5. So, using the 6 MPa in the given pressure at 0.4, 0.02 megapascal, we have now the pump work at, wait, wait class. Ayan. So, balik tayo dito class. So, we have the pump work, we have 6.0289. From the pump work at the first class. So, we compute again for the enthalpy leaving the pump. Diba? Yung H5 natin. Dito yung class, Ito. H5. So, para hindi kayo malito class, for you to simply solve this, para mas madali, i-draw nyo class para mas maintindihan. So, this is from condenser, yung 4, yung pump natin, leaving is 5. Yan. Para makuha natin yung H5 natin. So, this one class, makukuha na natin using or computing for the enthalpy at 0.5. And for the work at pump 2, yan. Ano naman yung gagamitin natin class? Yung specific volume at saturated liquid at 0.2, if that is just equal to the specific volume at 0.6. Dito class. This is VF2. Ito class. Dito. Ayan. Equal lang siya sa specific volume at 0.6. So, the pressure now, yung gagamitin natin is from the pressure entering the closed feed water heater, which is 0.4 MPa in the pressure of the boiler. So, makukuha na natin yung work, the pump work at 0.2, which is 6.0682 kilojoule per kilo. That is now the work of the pump at 0.2. In solving for the specific or the enthalpy at 0.7, so from the pump again, if you cannot, ayaw niyang balikan, ito galing to sa feed water. This is now noted as, so this is a closed feed water heater. Ayan, balikan niyo dito. 6 and 7. Ayan, 6 and the leaving is 7. So, nakuha na natin yung enthalpy at 0.6. Hanapin natin yung enthalpy at 0.7. So, i-add lang natin na compute natin ang work of the pump. We have now H7. Ayan. Paano naman daw yung H8 and the H9? Ayan. Ito na yung magiging big question natin. The H8 and the H9, usually, if given the problem, usually, ito dapat yung formula na class in solving for the given enthalpy H8 and H9. Yan. Yan yung mga approximation natin para lang siyang ina-add yung certain work of the pump at a given pressure and the enthalpy at entering, which is 0.6. So, nakikita niyo naman ang figure from 0.6 to 0.7 and ayan, yung scattered lines natin or your dotted line natin from 0.6 to 0.8 at from 0.6 to 0.9. Since this is a mixing chamber, yan, dito klasa, ito, mixing chamber siya. So, pag mixing chamber class, automatically, when it falls or when two streams or two fluid streams, sa Gmeet natin, dito, so, since this is a mixing chamber, they are the definition or the properties or the working description of a mixing chamber. When two fluid streams are being mixed, so, same yung enthalpy natin. Ayan. same enthalpy. So we denote as H7 is just equal to the enthalpy at point 8 and enthalpy at point 9. Okay? Excuse me. So using that, we have now H7, which is equal to H8 and H9. Okay, take note of the mixing chamber. Excuse me. So, eto na question. Mahirap-hirap. And finding the energy balance at the closed feed water heater. Yan, magulo-gulo. So, dito muna tayo sa schematic diagram. Yan. Ano yung entering natin? MH2, the mass times the enthalpy at point 2. Ayan, highlight ko. So, entering MH2 plus 1 minus M from the first pump equal siya sa leaving, which is MH6 and the 1 minus M, H9. So, this is a closed feed water heater. Simplifying, we have MH2 minus MH6 equal to the 1 times M. So, ito class, you have this, the H9 minus the H5 in your algebra. So, kukunin natin yung extracted steam natin from the turbine. So, simplification, ayan class, yung M natin nilabas. And yung isa pang M. Bakit? Kasi kailangan natin siyang masolve. Using the equation, M is equal to H9 minus H5 all over H2 minus H6 plus the H9 minus H5. So, solving for the mass of the, or the fraction of the steam extracted from the turbine, yung H9 natin, nakuha na natin ha, and the H5. The different properties, nakuha na natin, H2, H6, H9, H5. So, we have now the mass of the, or the extracted steam. The fraction of the steam extracted from the turbine, we have 0. Excuse me. 0.1464. Okay. So that is now the mass. And the heat added in the boiler, sabi ko nga, wala pa naman on the basis of 1 kilogram mass. So, 1 times, ano lang to class? So, we have 260.99 kilojoule per kilogram. And the mass extracted, or in the condenser class, we all know that the mass bleeded, or the extracted mass of steam is 1 minus M. So, 1 minus the 0.1464 times the H3 minus H4, we have now the heat rejected. And heat rejected, heat added. And finding for the work net. Kung kanina class, we can make use of sa equation ni ma'am, we can make use of the work of the turbine minus summation of the work of the pump. Pwede naman class in finding the work net. This is another way of computing. Work net is equal to the heat added minus the heat rejected. Okay? So, this is now the work net, the 10,000 or 1,016.3398 kilojoule per kilogram mass. Bakit, ma'am, hindi mo ginamit yung work ng turbine? Mahaba-haba yung equation natin sa turbine, di ba? Yung dinerive natin last time. So, we make use of the heat added minus the heat rejected. Naintindihan ba? Di ba, pinakita ko sa inyo yung pag-derive ng work ng turbine? It is easier to solve the heat added and the heat rejected. Hahanapin mo lang si extracted mass. Same with the work of the turbine, hahanapin mo to. Pero mas madali nga lang tong work net and the heat added minus the heat rejected. Okay? So, yan. We have now the work net. Considered naman siya work net. And finding the thermal efficiency, ito naman class. Ayan. Kasi yung work net natin, equal naman siya sa heat added. yung work net natin, heat added minus the heat rejected over the QA. So, ito na, QA over QA minus QR over QA. So, the thermal efficiency now can be used as 1 minus the heat rejected over the QA. Yan. So, this is now the thermal efficiency in a regenerative Rankine cycle. Ayan. Dinerive naman para makita nyo. Okay, so pwede po yun, class. In a regenerative cycle, kadalasan ang hinahanap na natin ng work net is the heat added from the boiler and the heat rejected. So, yun na, class, yung simplification. Pero pag pinahanap ko sa inyo yung work of the turbine, you will make use of the equation that was derived on the feedwater heater. Kasi same lang naman yun, class. Same yung magiging equation mo sa open feedwater. Kasi dun pa siya sa taas, di ba? Magbavari lang sila dito sa properties at dito. Dito lang sila magbavari. Sa closed, sa points 2569. So, dyan lang magbavari yung open feed. Sa open feed water, yung closed feed water heater. Okay? Kung sa turbine, kung ano yung na-derive natin na equation, yun yung class yung hahanapin natin, di ba? Ayan. Yun class yung hahanapin natin pag sinabi kong open feed water to. Okay? So, ayan. Sa una class, pag na-solve na, madali yan. Kasi nakikita mo na yung pasunod-sunod. Pero pag ikaw na, mahirap na yan. Kaya, you need to practice a lot. I mean, you need to practice more in solving regenerative Rankine cycle. Okay? So, yun class yung ideal regenerative Rankine cycle. Lalo na kung lalagyan ko pa to ng actual regenerative cycle. Ayan.